How's everyone doing? I hope everyone is doing well. Today we are going to focus on kind of reviewing / cleaning up all of our different graphing techniques. Alright, we've gone through everything now. Rigid transformations, vertical stretches and shrinks, horizontal stretches and shrinks. So we need to put it all together. So we're going to kind of look at our general form of how we would write out a function and then talk about what does what. Alright, so we know that this negative sign does what? It's always going to reflect over x-axis. That's nice and easy. We remember that. Why? Because it's changing the y values. And where is this negative? It's outside the function, so it has to change the y values. Now, moving on from that, we can talk about this a value. This a value does what? It tells us about vertical stretches or shrinks. Now what I'm going to do is over to the left, I'm going to come up with some rules here. We know that the a value can do a couple of different things. If our a value is greater than 1, and I put absolute value bars, I guess I really didn't have to because we're talking about this negative as its own entity. If a is greater than 1, we know it's going to be a vertical stretch. If, let's write it like this, 0, that's a 0, is less than a is less than 1, then we know that it's going to be a vertical shrink. And what does that mean? That just means, is a between 0 and 1? Is a fraction or a decimal? Because then it would be a shrink. What happens when we take a look at the next part of our function, this negative b? Well, we know that this negative b does what? Or if it's a negative, we know it's going to reflect over the y-axis. Alright, we remember this. How? Because it's inside the function, which means it changes the x values, and that's what reflecting over the y-axis would do. It would flip the x values from positive to negative. Alright, we also know that the b value tells us about the horizontal stretch or shrink. Alright, so let's make a rule over here on the right. And actually, let me label this a little better so we don't get confused. Those are vertical. Now our horizontals are over here. What's true? Well, everything's kind of flipped, right? Now we're going to say if b is greater than 1, then we have a horizontal shrink. Oh my gosh, shrink. Right? We know this. If b is greater than 1, then what it's actually going to do is it's going to shrink our graph. And then we can go with 0 is less than b is less than 1, and we know that this one is the horizontal stretch. Okay. What happens with the rest? The rest, I'd say, is a little easier. We know that this c value tells us about the horizontal shift. And what do we know? We know if it's plus c, then you're going to the left, and if it's minus c, you go to the right. And lastly, the d value. We know that the d value tells us about vertical shifts. And we say that if we have a plus d, it goes up, or minus d, we go down. So the big takeaways here, and I know I've said it over and over and over, a and d, they're outside the function. They have everything to do with vertical. And then b and c. b and c are inside the function. They have everything to do with, you guessed it, the horizontal. the x-axis. Okay, so let's take a look. Let's see what we can do here. Always make sure that the equation is in the correct form and factored. All right, we cannot do anything unless we are in this form and we have everything factored. What do I mean by that? Well, I think we'll see in a couple of examples what I mean. For saying that we're in the correct form, though, hopefully you guys see as we move on to this first example, we are not ready to go yet. All right? Is it ready? No, we're not ready. We have some things to do to make this look more like our original function. So what does that mean? Well, let's take a look. I can definitely factor out a 2 from inside the function. So if I do that, now I am ready to go. Again, remember, I always want to have that coefficient of 1 with the x. Alright, so I want to move the 2 or factor out the 2 because now I can see all of my different transformations. I have a vertical stretch of 3. I have a horizontal shrink of 1/2. I have, let's see here, that's going to be 4 to the left and then also 2 up. Alright, so there are my 4 transformations. What do we do after this? Remember, we always want to get our growth pattern and kind of work off of our growth pattern. So I'm going to say that normally when I have a square root function, I have a growth pattern that is the inverse of the parabola or the square function, right? It's not the ones in the x, the ones are in the y, and this is where we do the 1, the 3, the 5, and the 7. Now what we have to do is we have to take into consideration both of our stretches and shrinks. So I know vertical stretch of 3, that's going to affect the y values. I'm going to have to multiply each by 3. And then a horizontal shrink of 1/2, well then that affects my x's by 1/2. Alright, I am now ready to go. So we start, make sure we find our starting point. We're going 4 to the left and 2 up. And from here, we now use our growth pattern. So it says over 1/2, up 3. Over 1/2, up 3. Then it says to go over 3/2, up 3. So 1 or 1/2, 1.5, up 3, good. Over 5.5, up 3. So maybe something like this. And this would be a sketch, something like that. Now one thing that I would suggest doing, find a point that's on your curve and plug it into the original to see that it makes sense. This one might be kind of tough because it's a fraction, but something like this, which is at -2, 8, let's see what happens if we plug it back into the original. Alright, so 3 square root 2 times -2 plus 8 plus 2. Okay, so this is -4. -4 plus 8 is 4, so 3 square root 4 plus 2. This is 2. 3 times 2 is 6 plus 2 equals 8. And that's what we wanted, right? We wanted to get the y value of 8. Perfect. Alright, so let's see what I mean by making sure that we are factored, that our equation is factored. If you guys notice, hopefully you see and understand, I'm not really ready to work on this yet. Okay, I can do some things. Let's take a look. So f of x equals, first things first, GCF, right? I can definitely take out a -2. When I do that, I am left with x squared plus 10x plus 25. Now again, still, I can do more with this. This is actually a perfect square trinomial. Hopefully you guys are starting to be able to recognize that. I know that I can change this trinomial into a binomial squared. And how do I do that? X plus 5 squared. Now I am ready to find out my transformations. I list them out. I see a negative. I know I'm going to reflect over the x-axis. Okay, let's see what else. I know I have a positive 2 outside the function, so that means a vertical stretch of 2. And then lastly, I see 5, and this will be to the left. Okay? Alright. We have a parabola. Why do we know that? Because it's x squared, square function. Good. We need our growth pattern for a parabola, which is 1, 1, 1, 1, 1, 3, 5, 7. And let's kind of see what's going on. Let's see, vertical stretch of 2. That means all of these will be affected by 2. That's probably all I will need. And let's try and graph this now. So it says left 5. Cool. We have to reflect over the x-axis. So use your head here. What are we going to do? Am I going to go over 1 up 2? No. I'm going to go over 1 down 2, over 1 down 6, or back 1 down 2, back 1 down 6. And that will give us our curve. Again, if you feel comfortable with it, you can definitely plug in a point to try and figure out if you are doing okay. That is a good strategy. Let's take a look at something like the next example. Alright, our next example, again, I'm going to ask you, is this ready? Is this ready? Hopefully you said, no, this is not ready. Why? I want to get that coefficient of 1 with the x, right? So f of x equals -3. That's all staying the same. What can I do here, though? I have a 1/4 out in front of the x. That means I need to factor out a 1/4. Well, when I factor out a 1/4 from 1/4 x, I'm just left with x. So that's good. What happens when I factor out a 1/4 from -3/4? What happens? You're left with -3. Okay? What I want you to think about is you're just basically dividing out or removing a 1/4. Or maybe ask yourself this: how many times does 1/4 go into 3/4? And that answer to that is 3. Okay? So now that we have our function, we can go ahead and list our transformations. Negative. Okay, we have a reflect over x-axis. We have a vertical stretch of 3. Boom, boom. Okay, we have a horizontal. What do we have here? Horizontal what? Stretch of 4. And lastly, 3 to the right. Alright, so we make our growth pattern table for a cubic function. Alright, we got 1, 1, 1. We got 1, 7, 19. Remember, the next step is to take into consideration the stretches. So a vertical stretch of 3 means, well, that's a 3, that's a 21. I don't even have to, that's all I'm going to be able to do. Horizontal stretch of 4, nice and easy, right? Okay. So we start taking into consideration to the 3 to the right. So I do it, boom, boom, boom. And then I go over 4. And then be careful here. If I'm reflecting over the x-axis, that means I'm going to be flipped. Usually a cubic goes down to up. We're going to have to go up to down, up to down. So I'm not going to go over 4 up 3. I'm going to go over 4 down 3, or back 4 up 3. And that will give me a decent picture of what this would look like. Okay? something like that. Now in this case, again, just to kind of go through this one, if you wanted to test a point, this would be at -1, 3. Well, what happens if we plug in -3, 1/4 times -1 minus 3/4 cubed? Well, -1/4 minus 3/4, that's just -1. So -1 cubed. -1 cubed is just -1. -1 times -3 is +3, and that's what we wanted. Okay? Cool. All right. Next section is a little different. Basically, we want to kind of work backwards now. I want to get an equation from our transformations. Now, this says it's a parabola. Hopefully you guys understand then that this is going to be x squared. But we need to take into consideration these different transformations. So a reflection over the y-axis, that means what? I'm going to have a negative b value. And a horizontal stretch by 2, well, what does that mean? That means that b is going to be 1/2, right? A horizontal stretch means that the b value is going to have to be larger than 1. Horizontal translation 3 units to the left, we know that. That means we are going to have +3 inside. And vertical translation 5 units down, -5 outside. Okay? Okay. Oh, I just realized you couldn't see any of that. All right, pause for a second. Take a look. I'm going to talk through this again real quick. Write the equation of a parabola, x squared. Reflection over the y-axis, -b, right? We know a reflection over the y-axis has to be inside the function. Horizontal stretch by 2. B is equal to 1/2. Again, horizontal stretches, are kind of the opposite of what you think. Horizontal translation, 3 units to the left, +3 inside, and then -5 outside. Okay, so now we have to put it all together. F of x equals, well, we said what? There's nothing to do with the a value, right? So we're just going to go ahead and start. We know we're going to have squared. We know that we have to have a -1/2 inside the function. And we know that we're going 3 to the left. So a +3 inside. Vertical translation 5 units down is just like that. One thing just to be careful, this is not right. Okay? This is not okay. You have to remember, we would have to factor this if we saw this, correct? If I saw this, you would have to factor out a -1/2, and that would change the c value. So just make sure that you kind of keep your b and then the x plus c kind of separate. Now it says to graph. All right, we can do this. We know that we have a parabola, so this will be x, y, 1, 1, 1, 1, 1, 3, 5, 7. All right. Here we go. 3 units to the left and 5 units down. Cool. We need to take a look, make sure we have everything. Horizontal stretch by 2. All right, we don't do anything with the y's, but we have to change all of our x's by a factor of 2. And then a reflection over the y-axis. Be careful on this, guys. Parabolas. Think about it. If I reflect a normal parabola over the y-axis, does that really change anything? No. All right, so I'm just going to kind of use my growth pattern to go over 2 up 1, over 2 up 3, over 2 up 5, over 2 up 7, and then kind of go back the other way. And that should be good enough to plot. All right, that is where I'm going to stop the video. The next page I think we might do in class, just because it's a little confusing and I don't necessarily want you guys to have to worry about doing that right now. All right, so hopefully this clears up any questions you may have on transformations. Please, please, please make sure to understand this front page well, the top, okay? All of these different aspects of the general form for graphing. This will be important to know. All right, have a good one.